we got part 3 of exponential functions today, part 4 tomorrow, test on exponentials on Friday. All right? So some of this stuff, guys, is going to look a little bit similar to stuff we've done the last couple days, but with a few new pieces. All right? What function are we going to use to express an exponential? Like we talked about this in the warm-up, we talked about writing a rule. What's that function we use? Someone tell me by raising their hand. What's the function we use to represent an exponential? Not for a word problem, like if I was going to write a rule or something like that. What's the function for that? We just talked about it in the warm-up. Not the word problem one, but the first set of problems we did in the warm-up. Ariel? Yeah, y equals a times b to the x. All right? Now, just like we did in the warm-up, if I'm going to write a rule, all right, I get a table, right, and it asks me to write a rule based on what's in that table. What is the a going to be? How do I figure out what the a is? We talked about this in the warm-up. How do I know what a is when I write my rule?
It's the number that corresponds. It's like the number below 0.
The number below 0 for one value, x or y?
For y.
For y, right? So, to summarize that, guys, it's what y equals. So I look at my chart, it's what y equals when x is 0. Right? And I know, like, Ashley's like, Mr. Oh my God, the homework last night was written the other way, and there was no 0, oh my God. I can tell you, on the test, all right, when we give you the table, it'll look like this. X, Y, all right? And any table we give you will have a 0, all right? Any table we give you will have a 0 on it so you can figure out what A is, all right? Now, when I write an exponential based on the chart or based on the table, how do I figure out what Y is? How do I figure out what B is, I should say. How do I figure out what B is? So A is what Y equals when X is 0.
Oh, so writing that one down.
Yeah, you have a little, you want to write in, just in case you didn't have it, guys, write in, you have Y equals, you can write in A times B to the X on your notes. All right? And then next to that, where it says A is, question mark, you're going to write this. What Y equals when X is 0. Remember, when I'm asking for this to express an exponential, we're not doing word problems. All right, we do word problems, that's when we'll do the other one we talked about yesterday. And we have the 1 plus the r, and then the other thing. All right, but we're not worried about that when we're talking about this. So when I'm writing an exponential, how do I figure out what b is? Meaning?
The number that y is multiplied by?
Yeah, what y is multiplied by each time. So what the y term is multiplied by each time. Remember, for exponential, you have to multiply. Linear is you add or subtract the y's. Exponential, you multiply. All right? So on your notes, where it says b is, all right, you're going to write what the y term is multiplied by each time. Good. All right, so sort of like we did, and sorry. So B is going to be what the y term is multiplied by each time. Good, Marissa? C. All right, so sort of like we did yesterday. On your notes, all right, you have example 1a. It says, directions say, see if it represents an exponential function. If it does, write a rule for each function. All right? So if we look at that, does that represent an exponential function? Yes or no? How many people say yes? It does. How many people say no? How many people aren't sure? Okay. People that aren't sure, why are you not sure? Like Liam, you said you weren't sure. How come? Okay. I think maybe this is about, maybe because we have these couple fractions at the beginning. I know as soon as we see fractions, some of you guys freak out. Don't worry so much about that. Look at the whole numbers. Look at the whole numbers. From 1 to 3. Huh? What do you mean 3, Ashley? Times it by 3, right. Times it by 3. Same thing's happening here. 1/9. If I multiply that by 3, I'm going to get 1/3. All right? 1/9 times 3 over 1. I'm going to get 3 over 9. I can reduce that. I'm going to get 1 over 3. So I just showed you guys how I can go from 1/9 to 1/3 multiplying by 3. So I'm multiplying by 3 each time. All right? Somebody tell me. In this function, Ashley, Aldana, in this function, what's A equal? Look at your notes. We just said A is. Huh? I'm going to finish first.
What y equals 1 x equals 0.
So look at the chart.
1/3.
1/3. All right. So A equals, Ashley just told us, A equals 1/3. Marissa, what did you say?
Where'd you get 3 over 4?
I'm sure I showed you guys, I was multiplying 1/9 times 1/3, times 3, but I can make 3 a fraction by putting it over 1. That's all I was doing. I just did this to show you guys that when I multiplied 1/9 by 3, I get 1/3. All right, just to show you guys. So A equals 1/3. Iselise, what about B? What's B going to be? 3, right? Excellent. Maggie, I don't even care about the numbers or anything like that. My function, what's it going to start with? What 2 things? What letter? What are the Y? What else should I write after the Y? There you go. Perfect. You got that part down. Y equals. Hannah, what's going to come after the equal sign? 1/3. That's my A, right? Very good. 1/3 times. What's the next thing going to be, Aiden?
And you're going to have to find your B,
Which you already have.
which is 3.
Yes, good. Put a little X with it. Perfect. There's your rule right there. It's an exponential because I'm multiplying. That's my rule. Don't worry so much about the fractions. Look at what you know. Then if you have to check these couple on your calculator, you can. All right, so that would be an exponential. That's my rule. So what we've done before, same kind of thing. All right, we've done that before. Let's look at this one. Now, look at the values. I can go back up. There we go. Look at the y values in the table we just looked at, and look at the ones we're going to do now. Obviously, they're different numbers, but what's happening? Good. They're in a different order. What do you mean, Ashley?
The phone number is the first and the.
So what's happening to the values of the y's here?
Wait, what?
The values, though, are they going up or are they going down?
Oh, they went up.
They're getting bigger, right? They're increasing.
Oh, those go down.
All right, so a little bit different. Vanessa, what's up?
It's like you're dividing.
Okay, it's kind of like we're dividing, yes. But the big thing I want you guys to see here is, in this, we're increasing the y values. In here, we're decreasing. We're increasing because we're going from fractions to whole numbers. We're decreasing because we're going from whole numbers to fractions. just in a different order. All right? Just a little bit of a different order. I can still write my rule here. All right? I can still figure out what my A is. A is going to be what? A is going to be 1. Very good. Now, B is going to be a little bit tougher. I want to let you guys know, when we're doing these, I want to let you guys know a little bit of a secret. When you're looking at your chart or your table, and your values, your Y values, are going from bigger to smaller. They're decreasing. You're starting with whole numbers, you're going to fractions. Your B is always going to be a fraction. Let me say it again. If you're going from your Y values are starting as whole numbers and going to fractions, your B value will always be a fraction. Every single time. All right? So let's go back up. Does anybody think they know what that fraction might be in this problem? Yeah, 1/4. I'm multiplying by 1/4 each time. All right? I can look at it all, like, when I think of it as like, oh, it's almost like when I go from like the 4 to get the 4 to 16, I'm multiplying by 4. But because I know I'm going from a bigger Y value to a smaller Y value, I know that my B has to be a fraction. So I just know I'm going to take that number and put a 1 on the top to make it a fraction. So if we're going from bigger to smaller, your B is always going to be a fraction. So if I was going to write that as now I'm going to write the function. What's the function going to be? What's the exponential function going to be? Y equals, Ashley?
1 times 1/4.
Almost. Y times 1/4 to the x. All right? Mr. A, do you want to show something?
Just that question at the bottom, right? You can, if you want to do it, you can.
Okay.
Or I can do it. I'll have that one second.
Okay. All right, so this is gonna, Mr. Hager, this will be the first one, right? All right, we go, Mr. Hager wrote it down, okay.
You're good, I'm just listening.
Okay. So I got, this is gonna be y equals. Okay, so the one on the left is the one that we did first. All right, this one here, y equals 1/3. The x should be up here. I'm sorry, mistake. Go fix that for me. So this is the first one that we graphed. All right, this is the second one that we graphed. How are those graphs? You don't have to graph them, guys. If you did, I'm not making you do that. But how are those graphs different? Antonio? One's positive and one's negative. Which one's positive, Antonio?
The example.
1A and 1B? 1A. Right? 1A is going up in a positive direction. It's going up up towards the positive numbers have a greater value. Right? What about the one on the left? It's going up in a negative direction. All right? What did we talk about yesterday when it goes up? It's called exponential what? Good. This is an example of exponential growth. It's going up to the right. Now, this one is what we're going to talk about today. When it goes up, but it goes in like a negative direction. Or we could say that it's starting here and falling. You got to think of it going this way, guys. It's falling down to the right. Huh? It's going to be, so this is exponential growth. This is what we're going to be talking about a little bit more today. It's going to be exponential decay. Right? It'll be exponential decay. So growth up to the right, decay down to the right. Growth, when I look at a chart, it's going to start with fractions and go to whole numbers. Decay, it's going to start with whole numbers and go to fractions. That's why it comes down so quick. Gaining value, losing value. Remember, it's always based on going to the right. So that's what the graphs would look like. Okay? Now, let's summarize. We just talked about this. All right? If a table of data represents exponential growth, what's going to happen to the y values? They're going to increase, right? Good. So on the back side of your notes, on the back, we'll come back to that next part. So, for an exponential function to represent exponential growth, the v value, all right, will increase, all right? So for your little blank there on the back side, you're going to write increase. If you want to write it next to it in parentheses by multiplying by a whole number, that's up to you, right? Because if we're increasing, we're multiplying by a whole number every time. We're starting with fractions, we're going to whole numbers. Jordy? How's that? We're on the back side now. And like Mr. Hager showing up, this is what it will look like. It's going to go up to the right. It's going to start with fractions and go up towards the whole numbers. Okay? If a table of data represents exponential decay, all right, what's going to happen to the y values? Down, or we used increase, it'll decrease. All right? So on your blank, you want to write in will decrease. What?
Spaces that say that in the front.
Oh, the front, I'm sorry. Oh, I'm sorry, guys, on the front side. All right, in the middle with the two dots, I'm sorry. With the two dots, all right? We'll fix that stuff after.
I wrote on the wrong one.
Yeah, I'm sorry, I screwed you up. So if a table of data represents exponential growth, you want to write increase, and then will increase, and then the bottom one will be decrease. For those two bullets in the middle, the top bullet will be increase, the bottom bullet will be decrease. I got ahead of myself, guys, I'm sorry. So increase for the top blank, decrease for the bottom. Everybody's okay with that? We'll come back to the ones on the back in a second. All right? And Mr. Hager is showing you guys down to the right for it to be decay. Down to the right. Starting with whole numbers, going to fractions. All right? I'm sorry. So increase and decrease. That's all you're writing in those blanks. Increase and decrease. Sorry. All right. So this one. There's one on the test that's very similar to this. All right? So look at this. Do the values in the table represent an exponential function? Yes or no?
Like, yes.
We say yes, okay?
Sorry.
All right, so on your notes, right, for A it says, do the values in the table represent an exponential function? All right? We would say, we know yes, all right? So now, where it says, is this an exponential function? If so, why? So we're going to say yes, all right? Because. Why is this an exponential function? What should we be looking at to see if it's an exponential function? Exactly. Yeah. Yes, because the which ones? The y values are being what? What operation? What operation, guys? Multiplied. All right? So yes, because the y values are being multiplied by 1/5 each time. Now, based on what we just said, right? So we're multiplying by 1/5. 1/5 is a fraction. What type of exponential is this an example of? Decay, right? Because we're starting with whole numbers, going to fractions. And also because we're multiplying by a fraction. All right? So I'm going to say you just add, if you want to add that to your explanation, that's fine. So this is exponential decay. Write a rule for the function. So what do we have to use to write a rule for the function? Right? Y equals A times B to the X. I know I'm going to start with Y equals. A is going to be what? A is going to be 1, right? Because that's what Y equals when X is 0. Times, what's B going to be? 1/5? What else do I need? Good. So that's your hint for these ones, guys. Because sometimes it's hard. It's like I got fractions in here. It's hard to know. But you can always remind yourself, because we're going from bigger numbers to fractions, you're going to say to yourself, okay, my B value has to be a fraction. It has to be. Right? Going from bigger to smaller, my B value has to be a fraction. All right? So that would be your rule right there. So on the test, we might ask you one like, if it's an exponential, explain to us what? Something's being multiplied by something each time. And then write the rule, like we did here. Good with that? I can move on? All right. Now we can get to that part. Now we'll get to that backside, where we were earlier. If you have to scratch out what you wrote, that's okay. All right. So, for an exponential function to represent...
I can't decide on both.
Okay, that was weird. For an exponential function to represent exponential growth, what is the B value, or the number that's attached to the little exponent? What would that value? It has to be what kind of a value? It'll be what kind of a value? If it's exponential growth, what's it going to be multiplied by each time? A positive number. Okay, what else? Whole number or a fraction? Whole number, right? So it's going to be greater than 1. All right? So where it says will be, you're going to write, scratch out what you wrote originally, and Mr. Willie screwed you up. And I want you to write greater than 1. That's greater than a positive 1. We don't want any negative numbers. That changes everything. All right? So it's going to be greater than 1. That will be exponential. If we're multiplying by a number that's greater than 1, a positive 1, then that's going to be exponential growth. All right? Now, if we're talking exponential decay, all right, our range of numbers gets even more specific. What would that range of numbers be? Right? So for the B value, the number with the little x as the exponent, what's that B value have to be? Or what is the value? What range of numbers does it have to be between? Huh? Not less than negative. We're not talking about negatives. It's going to be between two numbers. Perfect. 1 and 0. Good, Vanessa. All right. So it will be between 0 and 1. Somebody give me an example of a number between 0 and 1. It could be a fraction or no, that's higher than 1. 0.25. 0, as long as it has a 0, right? It could be 0.352. All right, that's still going to be in between 0 and 1, as long as it has a 0 at the beginning. 1/2, 3/4, 3/5, 4/5, anything like that, as long as it's between 0 and 1. Now, Mr. Hager says here, proper fraction. What's an improper fraction? Proper fraction means the number on the top is smaller than the number on the bottom. What about improper fraction? The number on the top would be higher. That could be like 5/2. If I was to simplify that, guys, that number will come out bigger than, that number will come out bigger than 1. It would actually end up being 1.5.
It'll be
Yeah, 2 over 1.
2,
That'd be 2, I'm sorry, it'd be 2.5. Yeah,
2.5.
yeah, it'd be 2.5 for that one.
There's 2 holes and then.
Yeah, so you gotta make sure that's a proper fraction. Number on the top is smaller than the one on the bottom. So that's one little way to decide, looking at the chart, if it's gonna be exponential growth or exponential decay. All right? Let's look at some now and see if they're gonna represent exponential growth or exponential decay. So now we're looking at example 3A, 3B, and 3C. So all you're gonna do is just look at it and say exponential growth or exponential decay. What should we be looking for to tell us what the B value is? What's it going to have with it? No? No? Remember, like, if I was looking for slope in like y equals mx plus b, how do I know where the slope is? What's it going to have with it? The x, right? For this, when I'm looking for my b value, what's going to be with it? The little x as the exponent. So to determine what you're looking at, all you're looking for is what has the little exponent attached. The little x as the exponent. So the power, or look at the thing that's the power of x. All right? So let's look at these, see if the exponential growth and decay. So on your notes, you've got 3a, 3b, 3c. You have to write the function, and then we're going to determine if it's growth or decay. So here's 3a. There's your function right there. Y equals 0.54 to the x. So you have to write that down in your notes for example 3a. Make sure you leave yourself a little space too so you can write below it whether it's growth or decay. So y equals 0.54 to the x. Is that going to be growth or is that going to be decay? What do you think, Marissa? Decay, why? Yeah, but don't get tricked. What if it was something? What if we had it written out like this? What if we had something like that? Is that going to be growth or decay? No, it's still going to be decay.
Because the b is still less than.
What's in my function y equals a times b to the x? What's 2? What is 2? 2 is a, and then 0.54 is b. That's why I'm saying, look at the number that has the x as the exponent. That's what you're looking for to see whether it's growth or decay. Right, Ty? Okay. Just making sure. All right, so this is going to be, so don't get tricked here. You're always looking at the number that has a little x attached. This will be exponential. Oh, stay right, you're going to, I'm not doing that, okay. Exponential. Oops. Exponential decay. All right, don't get tricked. You're only looking at what's inside the parentheses that has a little x with it. This will be exponential decay. 3b. Now you got y equals 3.0221 to the x. Y equals 3. Liam, Aiden, you writing this down? Y equals 3.0221 to the x. Is that going to be exponential growth or is that going to be exponential decay? Growth, right? It's still a decimal, but there's a number greater than 1 to the left of the decimal point. So this will be exponential growth. All right? Last one. Y equals 0.993 to the x. Y equals 0.993 to the x. Maggie, growth or decay? So let's reflect, look at your notes, right? What are the rules for growth and decay? If it's greater than 1, it's going to be what, guys? If it's between 0 and 1, it's going to be what? What range of numbers is that between? Is that greater than 1 or between 0 and 1? Between 0 and 1, so it's going to be what? Okay. All right? So this is going to be exponential decay. All right, that'll be exponential decay. It's close. We're getting it's closer to 1 because we're at 993, but again, it's not greater than 1. Could have been that too, but it still would have been decay because it's not greater than 1. All right. So again, on the test, guys, we're going to give you two functions, and we're going to ask you, okay, pick the one that's exponential decay, or we could ask, pick the one that's exponential growth. Okay. Now we got. There you go. All right. Now we're going to graph it. We'll graph an exponential. And we're going to identify the domain and range. So, looking at this, look at that function. Is that going to be growth or is that going to be decay? Decay, right? Because how come? Say again? It's in between 1. It's in between 0 and 1, right? Half is right smack in between 0 and 1. So it's going to be decay. So where would our graph, where would it start? Would it come start like this and go up? Or is it going to start here and go down? Down, yeah, it's going to go down to the right because it's decay. All right.
I did the graph so you can focus on domain and range.
Okay. So Mr. Hager just drew the graph. All right. He just put the points on there. On the test, guys. Before I even start this, what should I do? Even though it's not there, what should I do? I'm going to set up my table. When I do this, I gotta set up an XY table. All right? So, for this, when I find my y values, how are they going to start? What type of numbers am I going to have? What type of numbers am I going to have first? Am I going to have whole numbers or am I going to have fractions?
No,
It's decay, right? It's going to start as whole numbers and then go to fractions. All right, so I know when I do this, I'm going to start as whole numbers and I'm going to go to fractions. All right? So, all I'm going to put here is, I'm going to take this, my function, and just write it here. All right? I'm just taking my function, and I'm writing it here. Just like we talked about on Monday. I don't care what kind of an exponential we're asked to graph, whether it's exponential decay like we have here, or exponential growth that we've already done earlier in the week. We're always going to use these numbers. We're always going to use -2, -1, 0, 1, 2. We're always going to use them. Every time. Every time we graph an exponential. Okay? So, when I set up my first, when I plug in for my first, set up my first function, what's it going to be? Ashley?
y equals 1/2 and then -2
1/2
as the x.
to the -2.
Then since it's a negative, you gotta flip it, so the 2 would be at the top and the 1 is.
Now remember, because it's like this, all right, I have to, that -2 is going to both things. It's going to the top and the bottom. So it's going to be 1 to the -2, 2 to the -2. Then I'm going to flip it, right? What's going to go on the top, Aiden? 2 to the second, because moving it makes it positive. And on the bottom? 1 to the second. All right, what's 2 to the second going to be? 4, right? You get away with it on that one because 2 times 2 is 4. But if it was like 3 to the second, you said 6, you'd be wrong because it should be 3 times 3. I'm going to get 4, 1 to the second, 1. What's 4 over 1 mean? So, yeah, anything over 1 is itself. Now, if this kind of freaks you out, if you punch it in on your calculator, you can do it exactly the same way too. It's entirely up to you. You can punch it in your calculator. Mr. Hager's going to show you guys right now. So remember, it might be a little bit different on Mr. Hager's calculator, but the little ABC button on your calculator, that's going to give you a fraction. So same thing. If you plug it in on your calculator, you get the same thing. You can avoid all those steps. All right? Now negative 1.
That's the one I just typed in.
That's what you just did? Well, Mr. Hager just showed you guys how to do that one on the calculator. He just did 1/2 to the negative 1. He got 2. Now he's doing 1/2. 1/2 to the 0 is easy, right? What's it going to be? Anything to the 0 power is 1. Nice job on that one, guys. How about 1/2 to the 1? What's 1/2 to the first power? 1/2, right? And we talked about this a couple weeks ago, guys, when we did our intro to exponents. Any number can be written to the first power, we just don't write it every time. Every number can be written to the first power. It's just that number. All right? And Mr. Hager, he did it as a decimal here, you can do that too. And then he'll do 1/2 to he's going to do 1/2 to the second. It'll be 0.25. If I want to do that as a fraction, what would it be? 1/4. All right? And on your calculator, guys, I think there's like a little, it says like FD. If you hit that, it comes out as a decimal. You want to change it to a fraction, you can just hit that button too. It'll give you a fraction. All right? So, Mr. Hager already graphed it. We talked about domain and range. God, that was probably back around like Thanksgiving time. That was a long time ago. Does anybody remember what the domain was? Yeah, good, right? Kyle says the domain is the x values. What about the range? The y values. All right, the domain is the y values, which Mr. Hager just wrote here. So it's just asking me to identify the domain and the range
Of the graph.
of the graph.
Yeah.
Okay. Oh, the distance.
So we all do this.
Oh, okay. You say, you want to do this, Pat? I'm not sure what you're looking for. I know we did this last year. I just don't exactly remember.
So the domain here for the x's, these are just 5 specific values in the domain. But the domain in general is every x on this red line. It includes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How far to the right does that red line keep going? Forever. And now, it doesn't look like it's going to the left as fast, but even though it's going up, it's still curving to the left. So how far to the left is that red line going to keep going? Forever. Okay? Even though it looks like it's going up, it still kind of does something like this. It goes up, but it still slowly goes to the left. So if that red line goes left forever and right forever, what values does that include? All of them. Okay, so the domain is all real numbers. All reals. So the domain is everything forever, left to right. Now, how about up to down? That's the range. Okay, so think of this as left to right. Does this graph go up forever? Yes, it does go up forever. Does this graph go down forever? No, it kind of levels out. And it levels out at what number? It levels out at 0. Okay, this is 0. So it goes up forever, but it levels out at 0. Now, will this number ever reach 0? Like let's try 1/2 to the third power. Get 1/2 divided by 2 divided by 2 to the third power. Is that 0? No, it's closer. Let's try one even bigger. What do you want to try? 1/2 to the 46th power? Oh, let's not quite go that big. Let's try 10. Okay, it's 0.00097. Is that 0? No, it's getting closer though. It's getting closer and closer to 0, but it's never going to be 0. So how would you write that? If it includes every number that's just above 0 and up. It would be all numbers that are above 0. Exactly. This is every number above 0. So all reals greater than 0. It includes every single number greater than 0. Okay, so when you have a graph, that's how you want to think of it. Domain, left to right. Range, up and down. And for exponential functions, unless we do something a little more complicated, this is pretty much always the case. We could have a different graph that maybe it curves down slower. Maybe it does something like that, but it still goes up forever, and it's still going to go to the right forever. Okay, so pretty much this is always the answer with the types of problems you guys are going to have. It's not always the answer in general, but for our problems it will be. So any questions on that? Okay, what about if I had a graph of, which one was this, decay or growth?
Decay.
That was decay. So what if I had growth? How far left and right does that graph go? It's the same thing. This graph goes to the left forever, and it keeps heading to the right forever, even though it's kind of heading more up. It's still heading to the right. So what would the domain be here? It would be all real numbers. Now the range. Does this graph go up forever? Yes. That's why this arrow's here. It keeps going up. Does it go down forever? Think, Kaya? No, it doesn't go down forever. So the range isn't all real numbers. What's the lowest that it goes? 0. It doesn't go any lower than 0. It's not like it comes down like that. Okay, it doesn't go below 0. So it's only numbers greater than 0. That's it. Any questions on that one? All right. I think it's the last one.
Yeah, we've already done this kind of stuff. Shouldn't be too bad, Mr. Hager.
Okay, so this is describing, it's got two functions, and you're going to compare this one to that one. Now, the only difference is your number here is now a fraction. What happens when b is a number less than 1? It's not growth. It's decay. But you still describe this exactly the same way we've done
Guys,
before.
if we're comparing, what's the phrase we use? Good. A vertical stretch, good.
So this is a vertical stretch by a factor of what? Of 3.
Yep.
That's all you write. Vertical stretch by a factor of 3. Now, when do you have to add a second part to that? If what? If it's
When what's negative? The number outside the parentheses or the number inside the parentheses? Good.
So what would be your start of your sentence here?
Vertical
Good.
stretch by a factor of 1/3.
Okay, let's stop with that for a second. Vertical stretch by a factor of 1/3. What does that really mean? If you stretch something by a third. Like think if you take the number 12 and multiply it by a third. What really happens to it?
Usually, like,
What's happening if you stretch by 1/3? Or think of it like multiplication. If you say you had the number 12 and you stretch 12 by 1/3, what would happen to the number 12? It actually gets smaller. So when you stretch by something that's a fraction, it actually compresses. Right? So vertical stretch by 1/3, which means it's actually shrinking. And what else? Yeah. And what tells you it's flipping over the x-axis? The negative. Okay, so that's the same thing we did yesterday, and I think we did it Monday too.
Guys, so we've talked about this a couple times this week. Tonight, part 3. Tomorrow night will be everything, right? Tomorrow night's the reference sheet homework. Remember, tomorrow's the last day of new material for Algebra 1A. You made it. Everything else from there on up, the homework for tomorrow night will be reviewed, and after that we'll start reviewing for the final. Remember, last test is on Friday for this quarter, so if you're kind of skating on the edge of passing or failing, right? I won't be after school tomorrow, but Mr. Hager will if you want to stay. No class next academic Monday. The final exam is 2 weeks from Friday.